Okay. Right. So welcome back, and I would like to give you a information that I believe we will finish chapter 2 in this week. Okay. So next week, Wednesday, we will have a quiz. Okay, for chapter 1 and 2. All right, chapter 1 and 2, and it will very similar to the problem that the teaching assistant suggests you in Facebook club, right? Right. You remember teaching assistant post a post that the problems in the textbook examples. Check. So next week. So should be 26th of March. All right. I'll write down here. So quiz. First quiz should be on 26th of March. March. All right. So please be prepared. All right. Okay, be prepared, and it will be really exam will be really similar to, and I'm not sure if the quiz hour should be 30 minutes, 40 minutes, or 60 minutes. I haven't made a decision. All right, so I will let you know if if I'm busy. I will make it 40. All right, 40 minutes. If I'm not busy, and I can after your quiz, I will keep doing the lecture. All right, so I haven't decided yet, but I will let you know. All right, but I'll highly recommend you to practice all the problems that the handouts and also the problem that proposed by teaching assistant in the Facebook club. All right, so please go on the Facebook club and then to see which problems that you need to practice. Of course, I will encourage you practice more. Okay, but at least I believe you need to practice all of them, and you will definitely have beneficial for your score. All right， 听得懂吗？就下礼拜3、26号，3月26号我们会有一个小考，这小考就是1、2章的，就1、2章。好，是吧 ？OK， Chapter 1 and 2 ，Chapter 1 and 2. All right. Right. So let's continue our lectures. Last week we introduced sorry, maybe you need to 期中考 midterm should be including chapter 1, 2, 3. All right. So depending on my I'm not sure if I can finish chapter 3 within 2 weeks. If I could do that, it will be in a normal midterm week. But if I cannot finish that, it will be the next one. Okay, so either 8th of April or 15th of April. All right, 2 of them, suppose. But I'm not really sure that based on the schedule, the progress of my lecture. All right, so yeah, let's continue. So last week we talked about the stress element, which is a really important concept that if you have a loading and your loading will cause the material point in this material, Each material point has the stress element, stress, and the material point can be referred to stress elements, and the element should be looks like a cubit. The reason why we use cubit because the cubic surfaces can be regarded as the orientation. Okay, the orientation, and each orientation represents the component of the stress. So in each point, they has one single stress status. But if you choose different coordinate or choose different orientation of material, you can see different component of that stress. So if you choose this direction, if you choose, and then in this page, we introduce how to determine the component of the stress and the relationship between sigma x and sigma x, sigma x and to the sigma theta and the tau theta. So the theta is the orientation you choose. And on that surface, you may have the normal stress and shear stress. All right. Also, I would like to emphasize one thing is that in material science and engineering, in mechanics of material science, in this course, 90% of the proof of the problem is followed similar procedure like this. You can use stress times the area become force. And then if you have force, you can either do balanced force or you can determine the corresponding stress. 听得懂吗？就是说啊，90%的财力证明啊，这门课的90%的证明都是把应力乘上面积，然后变成力，然后力完以后要么就是叫什么？就是力平衡啊，然后求出你要的关系，或者是你再把那个力啊，去经过一些运算以后，回到它就是接下来的 sigma，就是相对应的应力值。好，所以说90%都是这样子，把它转成力，因为应力是不能平衡的，但是力是可以平衡的。那所以说你要先把应力转成力，然后来平衡，你就可以得到很多的关系，大概是这样。90%哦，真的，你到时候可以看。Okay, so the reason why is that stress cannot be balanced. Force can be balanced. Okay, so almost first step is that transfer sigma to the force by times the area. Okay, right. So yeah, this is the result we take. And then because this result has cosine and sine in it, so which means that it has maxima or minima. So maxima, which means that you have the theta to substitute certain values. Okay, so you can have different condition. And most important, so for example, if your theta equal to 0, which means that you focus on this surface. Okay, if you have a PP tensile, okay, if you substitute theta equal to 0, which means that you only have sigma x, no shear stress. And if you choose theta equal to 180 degree, which means that you choose this area, you can imagine that this area rotate 180 degree, become this area. Okay, this area is 180 degree and also has sigma x, no shear stress. This is the result. You substitute 0 and 180 degree, you can obtain this automatically. All right, then if you substitute 45 degree, which means that you focus on this implant, this plane or surface, and then you automatically obtain two values. The first one, half sigma x. The second one, shear. is also half sigma x. Okay? And then if you substitute 135, you get this. Okay, and I will tell you more later. And one important thing is that A and B, although I draw it apart, actually you can treat that as the same point, the same material point. The only difference for this is you just choose different coordinate. Okay, they has exactly the same stress status, but you only choose different coordinate to draw the component. All right, so this is a really important concept. 我说这张图虽然看起来好像完全不一样，但实际上你可以说它们其实同一点的应力状态。应力状态其实是这样点是一样的。为什么它画起来会完全不一样呢？因为你只是画不同的 component 出来而已，你只是选择不同的坐标轴出来，然后你就会画出不同的分量出来。但是实际上当这一点的应力状态其实不变的，是一模一样的。哦，这是非常有点需要注意的地方。All right, so next one, I just draw this into a continuous figure. Okay, so again, the red one is normal stress and blue one is shear stress. And if you draw a sigma x and with zero degree, you focus on this one. All right, so you have sigma x, which is 0 degree, and you have the highest value. And if you have 90 degree, if you have your theta equal to 90 degree, which means that you focus on this one, this value. So sorry, this surface. And this surface, if you substitute 90 degree into your equation, you will obtain 0. Okay, your sigma x equal to 0. Or you can say sigma x1. The sigma x1 along the 90 degree orientation is 0. So 0 normal stress. Okay, so you see the value is just like a sine cosine, right? 0. Now, of course, here minus 90, you focus on this area, okay? This area. But yeah, again, this is 0. Then if we talk about shear, because there's no shear, right? No shear. So you can see that these 2 points are all, the blue line are all 0. But if you have 45 degree, okay, 45 degree, okay, you can see that the element looks like exactly the same, but only our main surface are not the same. Okay, the surface we considered are not the same. So this is minus 45. So you can see that this is minus 45, minus 45. All right. And this area, this angle is minus 45. Okay. It's minus 45. Well, you should say 45. But when I draw this in the clockwise, right? Clockwise way for the 45 degrees. So I put 45, but actually it's not, if you substitute the value, it should be minus 45 degree. Okay, and here you got positive 45 degree, 45 degree. All right, and then this 45 degree has the highest value. Well, as you can see, highest value, blue point is highest value. You see, this is negative highest value, greatest value. greatest absolute value, but this is a minus, this is a positive. And then I will lead you later to draw the figure, okay? And again, another thing you need to see is that although in maximum normal stress, there's no shear stress, but when maximum shear stress occurs, it still has some normal stress. Okay, so you see, normal stress is at a certain value. It's not maximum normal stress. 就是说啊，你有最大的正向应力的时候，0度或180度的时，0度或180度的时候，你是全满的，但是你没有 shear stress。但是你如果是最大的剪力的时候，你却是还是有伴随着 normal stress， 还是有伴随着垂直的应力。好，这边要小心一点，不要以为说啊最大的剪应力哦，就全部都用在剪应力上哦，没有那么好。但是如果如果是 normal stress 的话，那就是全部用在 normal stress， 它分量可以直接全部在那边。好，然后这边我有一个地方写错 ，there's a mistake here， not zero. So you see, when shear stress is maximum or minimum, normal stress is not zero. It is very funny that, yeah, it's good that I can also use it as a, stress, emphasize on it. Right, if you can accept that, I will give you a first example and then you will understand what I'm talking about. All right, let's continue. This is kind of typical. And this is material subject to compression P equal to 90 kN, and area is blah, 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 P equal to 90 kN, and it wants us to find the sigma theta, tau theta at the theta equal to 25 degree. Okay, 25 degree. Okay, so let's take a look. And also it asks us to complete the stress of state. What does that mean? Just plot the orientation of the stress element and all the stress on it. Okay, so the answer should be looks like the value here and a figure here. All right, so when you write the problem in the quiz, you're going to write down the value and plot the stress element. All right, now let's take a look. So firstly, what is sigma x? Because the formula must sigma x first, right? Sigma x equal to P divided by A equal to A is 1.2 times 10 to minus 3. All right, MKS unit. Then here is really important. Please put your emphasis on this. This is 90 degree times 10 to 3, right? However, because remember our formula, our formula is based on tension, right? Tension is positive, right? We always assume positive, but now you are compression. You should be negative, okay? You need to be compression. So you need to be very very careful about this. So you got minus 75 MPa. So which means that your sigma x is actually compression, okay? Minus 75 MPa. So the first one, sigma theta equal to, well, this is easy, right? Just substitute all the value into the equation. Minus 75 cosine 25 degree square equal to minus 61.6 m/. Okay, so 6 sigma theta, when theta equal to 25 degrees, your component will be minus 61.6 m/. And this is tau theta minus sigma x sine theta cosine theta minus, minus 75. So be careful about this. The minus is there. So it will cancel the minus sign in 75. You need to be careful about this, all right? So all this value is important. All these signs are also important when you substitute the value. Equal to 28.7 m/, because it will determine the direction of the stress. You need to be really careful. So as you see, this is a minus, positive. Depending on the sign, the value, the direction of the arrow will be different. All right. So you finished the first one. How about the second one? Second one. Okay. So now let's draw a pink part here. And because the pink part is 25-degree orientation, right? So the problem 1 specified for plan AB only, because this is 25, right? 25. Okay, so actually this one is not related to this one, right? No. So now you are free to draw these two stress on this pink surface. The first one, sigma x, sigma theta is normal stress, right? And minus 61.6. So it should be minus, because it's compression, right? And also, you need to write down 61.6 m/. You cannot write direction with the compression, and then you write minus 61.6 m/. After you define the direction, plus and minus sign is not important anymore. Okay, because plus and minus indicating the direction. As long as you draw the arrow, you don't need to put any signs here, or you can just say this is the absolute value. All right. Next one, positive 28.7. So you can imagine that this is a x1 direction. This is y1 direction. Okay, so okay, this is x1 direction, this is y1 direction. All right, so you see this pink surface is in the positive x1 direction surface, and you need to have the positive shear to 8.7. So it should be along positive y1. So your shear stress should be go up along the positive y1 direction. Now, after you've done the first pink surface, remember that all the stress, well, the rest of them you can plot without difficulty. 61.6 m/, and 28.7 m/. And you see this rotate like this, right? These two arrows, these two shear force will rotate like counterclockwise. So it must be clockwise for these BC and BC and DA direction. So it will make this one 28.7, 28.7. All right. So we only use the information we obtained from question 1, problem 1. We can obtain this. But did I finish? Did I finish? No, because we still have a we haven't calculated that yet. So we only calculate the shear stress because of the concept that shear stress come in pairs, right? So we need to calculate further. Okay, this is green plan. Okay, green plan for second problem. So for phase BC. So now we focus on green plan now, not pink plan now. Okay, be careful. So here the theta become 25 degree plus 90 degree equal 115 degree. So you can imagine that this x1 and y1 now is here. Okay. Okay, so you can see that this okay become 115 degree. Sorry. Theta equal to 115 degree. Okay. Then let's substitute sigma theta for BC. Okay. Sigma x cosine cosine square 115 degree minus 75. Again, this minus 75 come from here. All right, sigma x. And cosine 115 degree equal to square equal to what minus 13.4 m/. Okay, now actually you finished this problem because in the green highlight plan BC surface BC, okay, it has minus 13.4. Okay, so you will have minus 15. Okay, so you finish the stress element. Okay, now I would like to invite you to, although you finished this problem, but I would like to check a bit. How about tau theta in the green plan? Minus sigma x sine 115 degree cosine 115 degree. What will it be? Minus 28.7 m/. Okay, this is a little bit confusing, right? You remember that this in total, this, suppose it is positive shear, right? Positive shear. But why comes negative? Why? Don't you think this is a little bit weird? Well, I would like you to see this problem in this way. Yes, you are right. I'm going to draw your neck. You are going to see things like this. Okay? All right? You need to see things like this. Okay? Yeah. So now your oh, should be smaller. You are going to see this green surface. What's that? Okay, that shape is your neck. So you can imagine that this is your focused surface. All right. So you see, you are focused on x1 and y1 in this direction. And because this is a positive x1 surface, and now you need to have a surface, stress, shear stress in downward to the y1. So it has to be minus. But in general, if you put the coordinate back to x1 and y1, it still fit, right? It still fit all the direction. It's still balanced quite well after you time the area. Okay, assume the area are all the same, right? 这样听懂我在讲什么吗？总之就是，哎，你刚刚看说你这样是正的。然后呢，理论上来讲，不是成对出现吗？哇，你把这边都推测出来了，好棒，你就不用算了。但是我想要请你 check 一下，你如果用绿色的当主角面，然后去 check 去算它的 sigma sorry shear，因为它负的，你可能觉得，哎，怎么会这样？怎么会这样？但没有关系，这只是因为这两个人的，就是粉红色跟绿色的坐标轴是不一样的 ，OK？所以你不能把它混为一谈。所以当你看到第二个式子的时候，你的头必须要扭成这样子，让它的 x1 在这里 ，y1 在这里，你就会发现，哦，这个方向的 shear stress 的确是负的，没有错。但是它每一个都还是跟原本的就是不管你的坐标轴怎么转，它的它的 stress 都还是长这样子啊，对不对？所以都还是符合的。所以回去你也可以试试看，拿主角面当做是这一个主角面，然后算一下这个值，然后这个主角面算一下这个值，然后看看它是不是方向都会维持一样 ，OK？ 一定一样的哈，但是可能正负号会不一样，因为你的坐标轴一直在转 ，OK？ 但是它的状态是不，这样状态是一样。So I encourage you to draw this and that back home, and you calculate the value, and you will see the positive or negative sign changing, but the direction always be like this. Okay, won't change. So I believe this is a really nice examples for you. Okay. 看来我可能画个口袋好了，这样就知道它是背面。这样好不好？不用2点，那2点很奇怪。好，这样它是一个口袋，它是背面。OK，所以你知道当个老师还要会画画，虽然画的不是很好看，画好一点。嗯，着色一下。哎，我是在等你抄哦，我只是没事。你知道小时候上课我都会画课本， 对，然后我就看，然后之后就发现哇，大家都跟我一样，然后不是有那种画杜甫嘛，还有李白嘛，然后那些人都超强，都是被念书耽误的漫画家呢。但说真的，在台湾要画漫画，说好像真的蛮难的哈，因为日本的这个竞争对手实在太强了，漫画实在太，他们的漫画实在画太好了，真的太厉害了。即便是我现在这么老了，我还是很喜欢看漫画。对，我现在还在追很多就是大家都在追的漫画，对啊，怎么会这么好看啊？真的是，我之前你知道之前有一个上学期有一个那个，就是我上一个门课叫固态热力学，然后固态热力学我当然每次上完课就像这样的时候，我就会随便讲一些事情，然后我那时候就有推荐，那结果我得到了一封 email，就是同学就寄给我说，老师你上课就是我很喜欢你的上课的 style，然后你推荐的动漫大档也很好看。他就这样子写一句，然后写 email 给我这样，所以就是没想到我随口讲一句话，然后他们就听了，这样，那蛮好看的，可以去看一下。嗯，好，就这样。Good. Next, this one. Maybe you will think why we need to see the different orientation component. Why? Because it will also tell you the weakness of the material. For example, this one. Ta-da. This one is the bar constructed by two pieces, first pieces and second pieces. All right, combined together by glue. Okay, by a glue, G, glue joint, glue 胶水啊。So it is a glue. Attach on it, apply on it, and then put it together. Okay, so this is and this material put on the table and subjected to the compression P. And so you can imagine that if you draw the force P, it should be like this, and you can make it, put it into, well, you rotate to right 90 degrees, and you can see this figure. All right, and this orientation become here. All right, and the P is 35 kN, alpha equal to 40 degree. So the 40 degree, which means that this inclined surface rotate from the x-axis become 90 degree minus 40. So it should be 50. Okay. So you can imagine that this is x1, and this is y1. Okay. Okay, so this surface has x1 and y1 direction, y1 axis like this. All right. Now, this material has sigma p allow. P is the maybe it's called plastic, maybe the blue material, and sigma g is glue. Okay, glue is 5.2 megapascal. Tau G is 3.4 megapascal, and the material in blue is P 4.0 MPa. So which means that the material blue has these breaking criteria, and glue itself has different different criteria for breaking. Okay, so it requires to find minimum width of B, the dimension of the area actually, So if I want to determine B, we should determine A. And if I want to determine A, I will determine sigma X, right? So let's do it backward to obtain the answer. Okay? So firstly, we want to find the sigma X. If we have sigma X, we can obtain B based on this logic flow, right? So let's take a look. 1. Sigma X for the glue joint. Okay, so you see the glue only occurred at the surface P and Q, right? So it's the minus 50 degree one. So okay, so you see 5.2 MPa equal to sigma X cosine minus 50 degree 2. But you need to be really careful about this. Is that correct? Let's take a look. If you have a P for compression, you will also you can imagine that the P is actually has a component is that okay? Oh, okay. It should follow. So this P for this surface issue has two components. The component which is normal to the PQ or parallel to the PQ. So you can imagine that the sigma X you are talking about, sigma X, is this in surface, and this P is going to compress it, right? So you will see that this is compression, which is minus sign. So you will have minus sign here. And again, if you have this shear direction parallel to that interface, the face, it belongs, it is on the positive x1 direction surface, but negative y1. So it also, the shear is also minus. Okay, so you can imagine that later you will also use minus 3.4, and this is minus 5.2. Okay, so this is a little bit difficult. You need to, pay attention on the direction. Otherwise, the value you calculate will be wrong. Sorry, not value, the direction. So sigma x equal to minus 12.6 MPa. All right. So if your sigma x, the sigma x, don't forget the x is indicating by this x. All right. Why? So this x, this x is based on this x. Don't forget that. All right. So which means that if you have an overall sigma x greater than minus 12.6 MPa, this surface will encounter compression break. All right. For the next one, minus 3.4, which is minus sigma x sine, which is substitute value to the equation. All right. Cosine minus 50 degree equal to minus 6.9 MPa. Okay, so which means that your sigma x over minus 6.9 as a compression, 6.9, it will fail. The glue joint will suffer from shear break. Okay. Next. Two, sigma x for the material P, or you can say blue material, right? The blue material has 7.5 equal to sigma. Oh, this one will be tricky, okay? 77.5 come from here, right? Come from here. And in compression, of course, you will say this is minus 70.5, right? And, okay, this is a little bit tricky now. Sigma x cosine A. What is the value of this? I know this glue joint only occurred at minus 50 degree. We know that. How about this? P is everything. P is the entire material. What is the value of the theta? Because now you are going to see the breaking criteria. So typically you are going to give the maxima. So where is the degree? Cos maxima sigma? Of course, 0 degree. 0 degree will give you the maxima sigma x. And if this maxima normal stress exceed 7.5, well, the 0 it occurred at that direction. All right. So I'll give you a 10 minutes break, and then please think about this, and I will continue in the after 10 minutes. If you have any question, just come here. Thank you.因为这个是 x1 嘛，不，这是 x 嘛 ，x 轴，然后这个面往顺时针方向变成这样的，也就是 x 变成 x1 了，它是往负50度的方向走。但是前面你发现这样子上是逆时针 ，x 变成 x1，它是正25度，所以这边是正的，记得吗？就是高中的时候那种三角函数的正负 degree 的关系，这样。
你这样讲话现在听不到。
哦，有错吗？没有。好，好险。OK。
哦，是这两页，然后什么两个上，不是4页哦，就是这个面整4面，它里面它2页是一张纸，跟一整个的。其实这个它就比较来点，现在我刚刚一直在讲两个，然后就是练习。我是你还是这个就是了解到这个这样子的现象的东西，就是前置的市场，就是那这个我觉得是就比较好。那么诚实发上去，因为是那个这个会成的时候，更加的开始这个会做这种不是有先找到这个先一个人然后找这个力量，你可以这样，然后跟他敲我的腿，就去年开始把我这个这种的。是，然后就是觉得这个状态，哦，就是这个频率，这个是叫我代表的那种频率，那个表示的要下一次事情，是个工程师，而且那招这个是做的非常仔细的到我们，因为他们就是研究那个什么样的有限的，这种编制研究，然后这个东西编制多少是这样我们的分类是不会，就是因为它算它的学分。就是我讲的，然后我和选对吧？一部分的是帮到主要是它的正单的福利，来去，来去，所以我认为是那种要的这个这个重要的，一个重要的才哦，就是啊，之类的。这个应该是下来的是，不是因为很有道理，是。
10分钟比我太快了。我只去买了2瓶饮料，然后去拿个包包就结束了，怎么那么快？是我动作太慢吗？哎，对了，我有分享那个蟑螂的平均寿命300天，这样算长还是短？
昆虫、甲虫大概1.5到2。
对吧？所以它很快啊，所以它在类哦，你一定有养甲虫对不对？小时候还是现在？对嘛，爬慢慢的，所以它就有年来计算，但是300天，哎，300天也蛮快要1年了啦。对啊，所以上帝是很公平的，又或者是人类跟动物的组成的那种极限，就是如果你要特殊的那种速度的话，你就是活得比较短。就这样子来看，BOSS 会不会活得比一般平均寿命短？或是那个F1赛车手啊，因为他们有比较快的那个反应速率，所以他就会活得比一般人都要短。那这时候就开始要讨论，就是人到底要活多长？你知道，你知道，就是老了应该说开始变老的时候，自以为自己是开始变老，但是其实他已经变老了，就是就会开始想一些有的没的，然后就想说这个人到底是活在这个世界上是有什么意义呢？然后还有在想说这个世界到底是什么？那我最近有一个新的 idea 可以跟大家分享一下，我觉得还蛮有趣的。就是我有一天看到一个 Facebook 还是 IG 忘记了推播我，就是说有一张照片，那张照片就看起来像是城市的大楼，然后有街道，然后讲城市的大楼街道，好像空拍图。当然那个影像就是有点特意弄得很模糊，就是黑灰灰的这样。然后他说你以为这是高楼大厦对不对？不对，它是 IC 的 chips。然后我看到这个就有一点难道我们我们人其实是地球这种生物的宅子吗？你会发现我们就在这个房屋里面，他们走来走去，走来走去，然后我们就从我家跑到这里来跟你们交流，然后再回家。我们其实就像红血球一样啊，到这边把养分输入到身体的每个地方，然后只是血球交换的是氧气或养分，我们交换的是 information。然后我们其实这整个地球的那个东西就是一个晶片，然后它在计算地球这个生物的某种东西，或是维持这个地球的生命。这个生命可能因为我们传递讯息，我们觉得传完就没了，对不对？但搞不好在超过3维的空间里面，我们传递的讯息在那个超过3维的空间，它其实是有东西的啊。然后它就开始在那个维度里面，其实地球是一个某种生物之类的。你不觉得？你不觉得我讲的好像还蛮有道理的吗？对不对？对不对？有没有这种感觉？然后另外一个让我有同样的想法，就是我去过西安交通大学，中国的西安交通大学，大概在快要8年前吧，我去西安交通大学参访姐妹校啊，的交通大学。你知道他们的交通大学是真的交通大学哦，是真的做交通的哦，做磁浮列车、高铁，叭那种东西。所以他就给我们看说，嘿，我们什么，我们内地啊，这个那个高铁的路线图，然后就给我们看，你看就真的，哎呦，就是血管，就真的是血管，就是公鸡的血管，或者鸡的那个，你知道鸡嘛？就是它现在那土地现在不是变成鸡的形状嘛？就血管啊，抓，然后我想说，人就在那个血管上面跑来跑去，然后传递不知道什么东西。那假设我们自己就是 地球的红血球，然后就传递一些有的没的。当然也不一定我们是红血球啦，我们可能是癌细胞，有些变成红血球，我们传递的是好的资讯，然后我们再顺便再破坏地球，我们就其实也是一种癌细胞，所以实际上。搞不好那个地球这种高等生物，它是超级高等生物，我们是无法理解的，大概是这样。我们只是里面的器官，其中一个小细胞，这样。我们是高等生物，因为我们有小细胞在帮助我们，但是我们可能也是另外一个高等生物的细胞，你不觉得吗？对，我觉得我讲的很有道理，对，供大家参考，就这样。好 ，OK, so let's continue. Should I translate what I said? I just saying that human being or animals may be the blood cells for the earth is kind of a higher level creature. Okay, so think about that. I think it's quite interesting. Anyway, let's go. So let's take a look. So you can see that the problem 1 is focusing on the glue joint. Okay, the glue joints actually only occurred at this surface. Okay, and the focus are always in this surface, right? So this should be 1. Problem 1. Okay. And how about problem 2? Problem 2 is the material. So the material has from 0 degree to 360 degree, right? So it has many possibility of the orientation, and you need to find the maximum one. And you cannot exceed the maximum one, otherwise it will break, right? So 2, the problem 2 should be focused on the 0 degree one, because the 0 degree one will give you the maximum normal stress. So this is normal stress, 0 degree. And it will give us your sigma x cannot exceed or greater than minus 70.5 MPa. Otherwise, this material will subjected to a compression failure. Okay, break. 为什么它一直在动的感觉？刚刚都没有。Okay, so that's the idea. Then, next one. For the shear one, shear. 4 equal to minus sigma x sine 45. Sorry, I shouldn't say the answer. 45 degree and cosine blah 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 degree. Okay, so firstly, we need to focus on this one, compression. P will cause the material if this compression should be, sorry, what does that mean? Sorry. Oh, okay, so let's take a look. If we are talking about the maximum shear stress, it should be 45 degree, right? Okay, so we know that we will focus on 45 degree to get the maximum shear stress. So we can say, okay, it should be, looks like this, right? And our focus on will be this direction, all right? Or we can lean down the bar. We plot this figure maybe here. Sorry, maybe here. Okay, this is a 45-degree element, and our focus is on this 45-degree. The 45-degree is that, you see, this is x direction, and this is x1 direction, and this is 45-degree. All right, so 45-degree, you see, if you give a compression, P, the component along this for the shear is, well, I'll give you a hub, okay? This P here, and it will has normal for 45-degree, and sorry, I shouldn't longer than this. Hey, and parallel to 45-degree. So you see, this shear is positive, and this shear, this compression, compress is negative. All right, so for 45-degree, it must has positive shear stress, okay, because it generating upward for y1 direction and in x1, positive x1 surface, okay. So it's a little bit difficult to, it's a little bit complicated. So sigma x equal to -8 m pa. So if you have a sigma x compression more than 8 m pa, the material will suffer shear break. So now, again, I'm going to ask you, we have 4 sigma x. Which one should I choose to build up to develop B? 1, 2, 3. Which one? How about English? Minus. Good, megapascal. The reason is, yeah, this is the lowest one, exactly. So we will choose this. We will choose the lowest. Yes, please give me the number. 1116. Okay, good. Very nice. So if we choose this one, then B squared equal to A, and A equal to P divided by sigma x, which means -35 kN divided by -6.9 m pa, and B equal to 71.2 millimeter. Okay, so that's the result. I guess the most difficult part is this one, and the pink sign. This is a little bit difficult, okay? As you need to identify this compression will produce what kind of positive or negative for particular orientation. This one is only for PQ -50, and this one is for this 45-degree. So you can see that minus and minus positive generated by the same load, but because you focus on different orientation of surface, you will have entirely different positive and negative. This is the first difficulty in this problem. And second difficulty in this problem is for the material that you don't have particular orientation, you need to considering the failure condition. You need to give the maxima 0 degree and 45 degree. Okay, so after you give the correct orientation degree, you will obtain the criteria of the breaking. All right. Next one. Wow, next one is so difficult. Next problem is so difficult. So all your senior will ask me. Previously, next page, I didn't include it in the handouts, but because of all the senior asked me, how can we solve this? Because this is really, really difficult. So I decided to include into the material, and yeah. Then, next one I will, well, I'll give you some time for do the note, and I believe maybe I will finish this today, maybe. Yeah, I definitely finish chapter 2 this week. Okay, so you will always have entire week to prepare the quiz. Now, next, so difficult, very, very difficult. All right, you can see that this problem is combining the statistically indeterminate and thermal effect and the orientation of stress component. So this is kind of composition of all the stuff in this chapter. Very difficult. And so also it tell us this is a really good problem. All right. So this problem is the material fixed at 2 wall. Okay. Clearly, this is statically indeterminate. Okay, because you will have 2 RA and RB. You don't know the value, so this is unknown, right? A RB unknown, but you only have one direction force, and also P is and it also has a P, so you can see that this is a load in the middle of the bar. So you need to, cut it, and this is really difficult. All right. So there is another material value. Right. The value will be in the problem 2.611, alpha equal to 95 times 10 to minus 6 degree C, and Young's modulus equal to 2.4 gigapascal. And it said this bar has this material, right? And the cross section is B equal to 38 and H equal to 75. So you can obtain the cross section area. No problem. Fit rigid support walls, okay, at room temperature 20, but with no initial stress, okay? No initial stress. Good, stress-free at the moment. When the temperature rises to 70, so increase 50 degree, all right? The compressive stress on and also with the P, okay, later. And the compressive stress on an inclined plane, PQ, at mid-span becomes 8.7. So you see the compressive stress compressive stress, sigma theta, equal to 8.7 MPa. Okay. If the allowable normal stress in 23 MPa and the allowable shear stress is 11.3 MPa. Okay. For the material blue, normal stress allowable 23, allowable shear 11.3. Okay, what is the maximal load P in positive x direction? Positive x, of course, to the right, which can be added at the quarter point, right? In addition to the thermal effects given, so 50-degree raise temperature, which can add to, and okay, without exceeding allowable stress values in the bar. Wow, so long. Okay, I will tell you in Mandarin. Okay. Oh, here is, this is not in, it is 23. All right, so this is a really long English problem, but I can give you a quick translation here. 就是有一个蓝色的棒子镶在2个墙上，然后呢，它的材料参数是这些啊，然后它的截面积是这个，它原本在20度的时候，但是升到70度了 ，OK， 然后呢，这时候它的 PQ 这个斜面上的压应力，也就是 sigma theta， 在这个线上是 8.7 MPa， 然后就怎样就算。然后呢，这个其实是有 A、B、C 3个小题，这个应该只是 C 小题，所以这个东西应该是跟 A、B 小题有关啦哈。所以 C 小题在这里 ，C 小题其实跟这个东西，这个8.7其实好像没什么关系了哈。好，就这样。那接下来他要问的说 ，C 小题就是说啊如果这个材料的allowable 就是什么容许应力是23，然后剪切的容许应力是11.3的话，你在中间要在1/4处加一个P力，而且是往正的哦，这边有一个正的哦，然后要加上去，可以加到多少？不会超过这2个其中一个，就是不会让它坏就对了。然后而且温度还在哦，你已经有热应力哦，升入50以后，然后你再加这个P力，它不会坏掉，不会超过这个应力的值多少。所以你会发现这真的非常非常复杂，对不对？难怪学长姐都不会。没关系，我们用系统性的解法，我们就慢慢的一步一步解，就是反正就先解嘛，管它的。we just follow a systematic procedure to do that, and don't be panic. Okay, don't be panic. Don't be nervous. All right. So let's take a look. So firstly, we will give you a equation of equilibrium. A plus T plus PB equal to 0, right? Because all assumed to the right, and the P is right by definition in the problem, positive direction x, right? So this equation must be correct. Next one. Okay, so now, because this is statically indeterminate problem, right? So the first one is equilibrium equation. And the next one should be compatibility equation. Remember that? So what is compatibility equation in this problem? It must be the total deformation between these two walls will be 0, right? So there are two sections. The first one is first section. You need to obtain delta 1 and delta 2, and also the increment of the thermal effect, and sum them up together become 0 because they are all defined within the wall, within walls. So what is delta 1? If I want to know delta 1, we need to know the internal force in the section 1. So how can I get the internal force? All I need to do is cut it. We cut it. Okay, so we cut it, and this is for delta 1. If we have normal force in this section, we know delta 1 because PL divided by EA, right? So N1, and this is RA. If we choose to put the left-hand side, all right? Next one, if I want to know the section 2 deformation, displacement, what should I cut? I can cut here. Okay. Wow, beautiful. And we choose to leave the left-hand side. RA is still there. N1 is not here, right? But we have P here. P here. And of course, N2. Okay, we assume the N2 and N1 are all in the positive direction. So this is delta 2. Okay, so again, compatibility equation, delta 1 plus delta 2 plus thermal elongation, delta T times alpha, and its original length, L, will be the delta for the thermal effect equal to 0, right? So first one is equilibrium equation. The second one is compatibility equation. And then, again, you know that delta 1 equal to what? Which is the P here. The P is the N1, right? So what is N1? Let's take a look. N1 must be equal to minus RA, right? Minus RA. Okay, how about N2? N2 equal to minus RA minus E. So now you know the value of N1 and N2. So delta 1 will be PL divided by EA. P, what is P? Which is N1. N1 equal to minus A. So minus RA times PL divided by EA. L, what is L? The L is, here is the first section, quarter of length. This length, quarter L. Divide by EA, no problem, easy. How about delta 2? Delta 2 is N2. N2 is minus RA minus P, okay? And how long will it be? 3 over 4L. 3 over 4L. 3L over 4, sorry. And EA, of course. So delta 1 and delta 2, I have write it down here. Now, we have delta 1, delta 2. So we can substitute that into the equation here. Okay, so what will it be? Although this problem looks really complicated, but we just do what we can do, right? Systematically assume the direction, assume and then cut it, and write down the equation of equilibrium, equation of comparability, and substitute that into that equation and see what we can do, right? So far, I guess everyone can understand what I'm talking about, right? But maybe you think it's still far away from the answer, but it's okay. Let's just do what we can do. That's life, right? 4EA minus RA minus 3RA minus 3P plus L delta T alpha equal to 0. Okay, so RA equal to minus 3 over 4P plus EA delta T alpha. So if I just substitute all the value we obtain here, we can have minus 3 over 4P plus 32.49 Kn. All right, that's, you see this kind of starting to make relationship between RA and P and values. That's good. So RA, we know that. And okay, and I don't know, should I make it, if I can make it saving some space. Saving some space. Okay, now let's take a further looks. One, the first section, all right. The first section, you can substitute your N1 plus RA equal to, N1 equal to minus RA, right? Equal to minus RA. So easy, N1 equal to 3 over 4 P minus EA delta T alpha. All right, I start from here. All right, so you just give it a minus side, so positive minus. All right, so your N1 equal to this one, and if you divide by the stress, so if you divide by the area, you can get the stress. If you get sigma x equal to, which is 3P over 4A minus E delta T alpha. All right, so sigma x equal to 3P over 4A minus E delta T alpha. And so this sigma x need to be less than what? 23 MPa, right? This value need to be less than 23 MPa. It said you shouldn't exceed that. How about tau? How about shear stuff? Maybe change to here. Okay, so for sigma x, how about how is tau max. Remember, tau max occurred at 45 degrees, right? 45 degrees give us sigma x divided by 2, right? So positive or negative sigma x divided by 2. If you forget this value, I will I will remind you here, all right, here. Remember that? 45 degree will give us half sigma x, okay? So I hope you remember now. So tau max should be positive minus sigma x divided by 2. So your tau max, tau allowed, you know that is 1.3 MPa, right? So your sigma x should be 22.6 MPa. You notice that, okay? So 23 MPa is actually greater than 22.6 MPa. So which means that this material will never achieve compression or tensile break, because before it will suffer shear break, because it has lower criteria to 2.6. If your sigma x arrive to 2.6 MPa value, it will break. It won't wait for 23, right? So this is, so you see what I mean, right? 讲中文就是说啊，我们这样算一算，我们发现我们的 sigma x 一定要小于23，我们这上面写的嘛。但是我们算 tau maxima， 它的值是45度来的，45度来的是正好是正负 sigma x 除以2。但是我们刚刚有讲，我就推算出来哈。那这时候人家 tau allow 只能 11.3 啊，那我们乘以2以后，就是说，如果今天 sigma x 超过 22.6 MPa 的话，它就会减力破坏咯。所以你看，这23比 22.6 还要大啊。所以实际上这个材料在还没有正向应力破坏之前，就已经先减力破坏了。所以这个东西其实是给心酸的，根本没有用，这才有用。好。So actually, 23 MPa, this criteria is actually useless, okay? Because it is greater than 22.6 MPa. All right. Right. So now we obtain more information from the first section. That's good. So again, so which means that if we combine the first section, the sigma x, this one must be less than 22.6 MPa. Okay, and it is positive or negative. So I'll give you a sorry. Okay, positive and negative is really important because the tau is actually has two kind of maxima, right? Two different orientation. So now please remember this. The first section, well, I just copy everything. This is really difficult. This is really difficult problem. So let's continue. So the first section, and delete it, delete it, delete it, okay, and move to here, and move to here. Okay, so the information is actually come straight from the previous note. Okay, you see how I continue this notes. You see, at the first section, the sigma x equal to this, definitely, because this is always true, right? But the value should not be less or set to 23, because it must be either 22.6 positive or negative. It will cause a break of the section 1. Okay, so if this is sigma x, this is P here, sorry, P here. Okay, so you can see that my sigma x can obtain P positive 22.6 plus 11.4 times 4/3 times 0.00285. Oh, it's too big. Okay, and which is equal to 22.6. Wait a minute. 11.4从哪来的？我忘记11.4从哪来了。等我一下哦。22.6加11.4， 11.4从哪来的？忘记了。等我一下哦，我脑袋忽然打结了。11.4从哪来的？我已经忘记了。我先要看我的小抄，旧版的小抄看有没有。为什么没有？为什么没有抄？为什么11.4？让我想想看啊。那3个乘起来，对，那为什么要？我看一下，那除以10，等我一下哦。这看起来好像是负的，但实际上不是。0.00285。哦，你是说就是50，不好意思，50乘上阿尔法再乘上1，然后就会是这个东西。OK， 很好，感谢你。可能我跳太快了，这样。好 ，Anyway， so maybe I jump too much, but if you substitute the if you sigma x, yeah, if you make all right, I see, you're right. So this is positive 22.6, right? And this thing's going to the right hand side and it becomes positive, right? And then times the 3/4. Yes, and divide by times a. Yeah, this is a. Good. Thank you very much. So Yoshun, can you give me your number? Thank you. 111 613 006. Oh, you are prepared, right? That's good. So thank you for your suggestion. So I should make it alpha like this, right? It should be like, hey, and then everyone will know this 11.4 is the result of E delta T alpha. And this one and that one. This one is this one, right? Is that correct? Good. Thank you very much. So equal to 129200 N. Okay. 129200 N, and P equal to minus 226 plus 11.4, blah, 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 blah. And the result, hey, we don't need to calculate that because you see here, because you see positive x direction in the problem. So if you have minus sign here, 2.6 plus 1.4, it will mix this opposite direction. So we don't need to calculate that anymore. We just say P is negative. All right. So it is not correct. All right. Not not match with the 太长了吧 description in the problem OK 题意不合啦，与题意不合的意思 OK because the problem said is positive x and now you calculate p is negative which means that your direction assumed is incorrect. No, it's not. Okay, so the first section and the second section will do exactly the same thing. Okay, the second section, I will do similar thing. N2 plus P plus RA equal to 0 and N2 equal to minus P equal to divided by 4 minus EA delta T alpha. So sigma x equal to minus P 4A minus E delta T alpha. Okay, again, very similar because section 1 and section 2 are in the same material. So this stuff will just copy to here. Copy. All right, we'll do exactly the same thing. Okay. So now P equal to minus 226 positive 1.4. Okay, and then you see this is minus P. So it becomes minus 4 times 0.00285. And it is 127,680N. And P equal to 22.6 plus E 1.4 times minus 4. Okay, we don't need to calculate that because P is negative. Okay, so again, you see that we have 2P. The first one is 129,200. The other is 127,680. So which one will be the answer? Anyone? 1, 2, 3. Okay. Yes, because yeah, you are right. Smallest or lowest. It's okay. It's okay. Both works. So this is answer. Okay. So what is your number? 1, 3039. Wow, you're getting better and better now. Kind of memorize it. Good. So this tells us if our P here apply 127,680 Newton, and also you have 50-degree raise of temperature, this material won't fail. Okay, or more specifically, won't shear fail. Will this material undergo normal stress fail? No, because shear stress is lower, criteria is lower than normal stress fail. Okay, so this is kind of how we dealing with that. This problem is really difficult. So I hope you go back home and yeah, study this a little bit. And this is a really good problem because it combines all the stuff in this chapter. Right. Thank you very much. See you tomorrow.好，请问
期中考，因为我14号到19号就期中考后那一周，我要去参加研讨会。那就是如果我期中考会放这一周的话，就是期中考后那一周，那我没有卡到的话，
对的，所以你到底是期中考后那一周还是期中考那一周？
期中考后那一周出国。
哦，OK，那我就尽量弄在期中考周就好了。
OK，
好，尽量，我试试看。
OK，那我如果真的不是卡的话，
那就很麻烦的。那我们再讨论。
OK，
好，再讨论。事情发生了，我们再烦恼。谢谢。